other type of problem we are going to review in this section is how to write a trigonometric expression in terms of a different trigonometric expression. This is going to be good practice because in the next section, you will be reviewing how to establish or verify a trigonometric identity. Okay, so if you remember what that entails is you will be given an equation and told that the equation represents a trigonometric identity, and you have to prove that the statement is an identity, meaning that it is true no matter what the value of the variable is. And in order to do that, you start with one side of the equation and then you use fundamental identities coupled with algebraic manipulation to arrive at the other side of the equation. And that proves that you're working with an identity. So what we're going to do in example 2, we are just going to have expressions, meaning there's no equal sign. Okay, so it's not an equation. All we're going to do is take our expression and we're going to try to simplify it or turn it into an equivalent trigonometric expression. Okay, this is, like I said, great practice in setting you up to review verifying trigonometric identities. Okay, so let's read the directions here in example 2. It says write each expression in terms of sine and cosine and then simplify the expression so that no quotients appear and all functions are of theta only. Okay, so those directions are a little wonky. Let's talk about what's entailed here. So let's look at part A. You can see the kind of expression we're going to be dealing with. Part A is cotangent squared theta times 1 plus tangent squared theta. There's no equal sign. That makes this just an expression. So essentially, we're going to be turning this into an equivalent trigonometric expression. Okay, something that's equal to it, but doesn't look exactly the same. Okay. In the directions, the way they want you to do this is to write each expression in terms of sine and cosine. Okay, so that's the first thing you see. So what that means is change everything to sines and cosines. Okay, so once you do that, then you need to simplify. Okay, and you're going to simplify so that there are no quotients. Okay, meaning in your final answer, your answer has no fractions. Well, let me say answer is not a fraction. And then we've got this other piece that says all functions are of theta only. Okay, so how you translate that? You don't want to see something like negative theta as your argument. Okay, all the arguments must be theta. Okay, so arguments must be theta. Okay, so those are some loaded directions. We basically had to translate the directions before we even start here. Okay, but that's what's being asked of you. Okay, so let's try the one in part A. Like I said, we have cotangent squared of theta times 1 plus the tangent squared of theta. Okay, we are going to take the advice of the instructions here, and I'm first going to change everything over to sine and cosine. Okay, so I'm going to first start with the cotangent squared of theta. That is the same thing. We know that cotangent is the same thing as cosine over sine. So we're going to write this as the cosine squared of theta over the sine squared of theta. Okay. Disclaimer here, since we're doing this, let me just do this with sine here. If you have the sine squared of theta, that is the same thing as the sine of theta times the sine of theta. This is not the same thing as the sine of theta squared. Okay, what the sine of theta squared is, that is the sine of theta times theta. Not the same thing. So my point here is when you're doing trig, you have powers of your trig functions, you need to really pay attention to where you put the exponent. If you mean that you're squaring sine theta, it is incorrect to write it this way, because in this expression, you're only squaring the theta, not the sine of theta value. Okay, so please pay attention to that. Okay, so sorry, I kind of got us off track here. So going back to the example here, okay, the cotangent squared of theta, that is the same thing as the cosine squared of theta over the sine squared of theta. Okay, and then again, I'm taking the advice here. I've got to translate the stuff in parentheses. This is going to be times 1 plus, I'm going to turn tangent squared of theta into sines and cosines. Okay, so this is going to be plus the sine squared of theta over the cosine squared of theta, because tangent is sine over cosine. Okay, all right, so we've done the first thing. We've changed everything over to sine and cosines, and now we've got to simplify. Okay, we don't want to see any fractions. All the functions are of theta only. We don't have any negative thetas floating around, so that's great. We just need to simplify so that we get rid of the fractions. Okay, my first instinct here is to distribute. I'm going to multiply the cosine squared theta over sine squared theta through the parentheses. So this is going to give me cosine squared theta over sine squared theta times 1. That's going to be cosine squared theta over sine squared theta. Okay, and then we'll keep the plus sign in the middle, and then we're going to have to multiply cosine squared theta over sine squared theta times sine squared theta over cosine squared theta. Okay, so I'm going to write that out. It's always best to write things out. You're less likely to make a mistake. All right, so this is how the distribution occurs. Okay, so let's keep going here. This is going to be cosine squared of theta over the sine squared of theta plus, look what happens in this right term. You have a cosine squared of theta in the top. It's going to cancel with the one in the bottom. And then similarly, you have a sine of squared of theta over a sine squared of theta. Those guys are going to cancel. You're going to be left with 1. Okay, so now we keep going here and we simplify. We've got to get rid of the quotient, which is a fraction. So we don't like this guy right here, but cosine squared theta over sine squared theta, you can change that back over to cotangent squared theta. So we get cotangent squared theta plus 1, and that is a Pythagorean identity. The cotangent squared theta plus 1, that is the same thing as cosecant squared of theta. Okay, this is your answer. Okay, it fits the bill of how the answer is wanted. Okay, we have simplified. There's no fractions in the answer. All the functions or the arguments are theta. Something that's really confusing about the directions, when it tells you to convert everything to sine and cosine, you may think that your answer has to have a sine or cosine in it. Okay, like you can't have any of the other trig functions. That's not true. Even though they want you to convert everything to sine and cosine to work the problem, your answer can contain any of the 6 trigonometric functions. So I'm going to write that up here as a note. Your answer can contain any of the trig functions. It doesn't have to be just sine or cosine. Okay, so this expression that we started with in part A simplifies to be the cosecant squared of theta. Okay, before we go to the next one, I want to mention something here. Okay, I'm going to put method 1 here. The directions tell you here that you've got to convert everything to sine and cosine. Okay, and you've studied trig before. You know that's not true. Okay, you don't have to convert everything to sine and cosine to change an expression into an equivalent form. Okay, so I'm going to work it another way. You're going to see we get the same answer, but it's not necessary to convert everything to sine and cosine. Sometimes it's a lot easier not to do that. Okay, so I'm going to put this in a different color. I'll write this second method in black. Okay, I'm going back to the original problem. All right, so here we go. When you look at this, immediately you should see 1 plus tangent squared theta. That is a Pythagorean identity, okay? So we could have started this problem not by converting everything to sines and cosines, but by applying the Pythagorean identity, okay? So here this would be the cotangent squared of theta times 1 plus the tangent squared of theta is the secant squared of theta. Okay, so now I'm going to change it over to sines and cosines. Okay, so the cotangent squared of theta, that is the cosine squared of theta over the sine squared of theta times the secant squared of theta. That is, secant is 1 over cosine, so secant squared of theta is 1 over the cosine squared of theta. And then when you look at this, you're multiplying your fractions. So you multiply across the top and across the bottom. You notice that you have a cosine squared in the top. It's going to cancel with 1 in the bottom. So if you multiply across the top, we're left with 1. You multiply across the bottom, we're left with sine squared of theta. 1 over sine squared of theta is the same thing as the cosecant squared of theta. Okay, we got the same answer. We just got there a different way. Okay, you should know this from trig. Okay, when you're doing this kind of stuff, there's several ways to get there. Okay, as long as you're applying the appropriate identities in the appropriate way, your work and answer should be correct. Okay, so my point of showing you this second method is that although the directions tell you to convert everything to sine and cosine, that is not a requirement.